All right, now we're going to talk about equivalent fractions and fractions that are in their simplest form, meaning they're written with the smallest numbers you can use. The cool thing about fractions is you get to use what you know with multiplication and division to change the look of the numbers, but we're not actually changing the value. This goes along with PW 110. The top question asks for a vocabulary, so I'm going to just help you with that. It said, a fraction whose numerator and denominator, remember the top and bottom numbers, can both be divided evenly only by 1 is in, your answer there is simplest form. Simplest form are the smallest digits you can use to write a fraction. So let's talk about what equivalent fractions are. Equivalent just means equal. They have the same value. Remember in the last video, one of the best places to start is to say, if you have a circle and you divide it into 4 parts, and you're talking about having 2 of those parts, your fraction is 2/4. But we already showed in the last video, and you guys already understand, that 2/4, if I only divided this same circle into into 2 parts, if I have the same size circle, but I divide it just into 2, and I take one of those parts, that has the same value. Same size circle, same amount of pizza or cookie or pie or whatever taken, but I write it in a different way because in this one I only broke it into 2 and I only took one of them. But 2/4 equals 1/2. How did we get there? We divided. Isn't that exciting? This fraction is going to be what we call simplest form. I'll show you. When we see 2/4, we are trying to always make numbers simpler and easy to deal with, right? That's why we sometimes turn things to zeros just to estimate or give ourselves numbers that go together when we're multiplying and dividing, because it makes sense right away and we can know if we're on the right track. Well, fractions, we want them to be in their simplest form so that we're not dealing with large numbers. So 2/4, when I look at this number, the way I'm going to try and see, can I simplify it? Can I make these digits smaller? I have to remember a couple of rules. The first rule, kind of like when we balanced equations, whatever you do to the left side, you have to do to the right. In fractions, whatever you do to the top, you have to do to the bottom. So you have to use the same expression, the same operation, the same digits to change them. I look at this and the first question I always ask myself is, can the numerator fit into the denominator? Is 2 a multiple of 4? Can 4 be divided by 2 is another way of asking it. And it can. I know that 2 times 2 is 4. So I can use the number 2 to make both of these simpler, because 2 is a multiple of 2, 2 is a multiple of 4, but to make it smaller, I'm going to divide by both. So I'm going to do this. 2 divided by 2 is 1, and because I did this to the top, I have to do the same thing to the bottom. 4 divided by 2 is 2. Because I stayed with the consistent numbers there, I get 1/2, and 1/2 is actually equal to 2/4. 1/2 is in simplest form because of that definition. I can only divide both of these numbers now by 1. There is nothing else they have in common. I can't divide by 2 or 3 or anything else because of that 1 on the top. Anytime you have a 1 on top as the numerator, you already know that you're going to be in simplest form. Let's try with another, just different fraction. And we will make some equivalent fractions. Let's do number 2 on your paper. Whee! Always helps when you get a few answers, right? 5/10. Because when we read fractions, the denominator always has a th at the end. Except for some of them like, okay, no. Now that I said that, halves, thirds, but then you get fourths, fifths, sixths, sevenths, eighths. 5/10. Your paper asks you to write 2 equivalent fractions for each. So let's first look and say, can 10 be divided by 5? Does 5 fit into 10? I know that's a basic fact. 5 goes into 10 2 times. Because 5 is a multiple of 10, I can divide by 5. 5 divided by 5 equals 1, because anything divided by itself is 1. I'm going to do the same thing that I did from the top on the bottom. 10 divided by 5 equals 2, 1/2 again. And that makes sense because when I look at this, if I said I have 5 out of 10 parts, I know I have half of the parts. So 1/2 is the same or equal to 5/10. But this one is in simplest form because I cannot divide any more. Let's make another equivalent fraction for 5/10, but we're going to do it using multiplication. Because here's the cool thing. If you can divide, we can also use multiplication to write larger numbers with the still representing the same fraction. 5/10. When you multiply, you have freedom to pick whatever number you want to use. So I'm just going to pick 3 this time. 5 times 3 to write an equivalent fraction. 5 times 3 is 15. If I do it to the top, I have to do it to the bottom. So 10 times 3 is going to give me an equivalent fraction. 10 times 3 is 30. 15/30 is equivalent or equal to 5/10. 15/30 is also equal to 1/2. Doesn't that make sense though? Because we know that 15 is half of 30. So we're just saying that if I had the same size of a whole thing, if I only break it into 2 parts, or if I break it into 30 parts, if I take 15 of those, I'm taking half. If I take 1 of the 2 parts, I'm taking half. Let me show you another one. Let's look at number 5 on your paper because that one's a little different. 5 on your paper says 8/20. So first I want to see, can I go into a simpler form? Can these numbers be divided by something they have in common? It's got to be something they have in common or it doesn't work. So can 8 go into 20? Can I do 20 divided by 8? Is that a basic fact? No. Well, what do I do now? Well, I start looking at my other options. Usually the next question I ask myself is, well, let's start simple. Are they both even numbers? Because even numbers can always be divided by what? 2. So I can look at this and I could say, let's just divide by 2 because that's a number they have in common. 8 divided by 2 equals 4. And 20 divided by 2, because what you do to the top, thou shalt do to the bottom, equals 10. One equivalent fraction is 4/10. Now I can look at that and I want you to tell me, is 4/10 in simplest form? Are those the smallest numbers we can write and they can't be divided anymore by anything other than 1? Raise your hand if you think, no, I can divide by something else. All right, I'm going to pretend I see some hands up, and you are correct. We can make this smaller. One way we test it is looking and saying, oh, there's still 2 even numbers. I can still divide by 2 if I want. So let's do that. Let's do 4/10. 4 divided by 2 equals 2. And 10 divided by 2 equals 5. So 2/5 is equal to 4/10, which is equal to 8/20. Those are 3 equivalent fractions. I've just written 2 more for number 5. And just as one last test, I want to look at this and say, is that in simplest form? I have to look and see, is there anything that these 2 digits have in common that they can both be divided by? They're not both even numbers, so I can't divide by 2. I can't divide by anything higher than 2 because I only have a 2 as the numerator, which means the only number they have in common now is 1, and that is the definition of simplest form. When these 2 can only be divided by 1, that's all they have in common, we are in simplest form. So when you're doing your fractions and you're trying to find equivalent fractions, first look at how you can divide. What do the numbers have in common? Because you always have to do the same thing. But if you want to write a fraction that is larger, or using larger numbers, it still has the same value. For example, on number 8, your fraction is 1/4. That's already in simplest form. You have to choose 2 fractions that are bigger numbers than 1 and 4. So you get to choose anything you want to multiply. When you multiply, it doesn't matter what you multiply by as long as you do the same thing to the top and the bottom. So if you choose for 1/4, maybe you just want to multiply by 2. 1 times 2 is 2, 4 times 2 is 8, so your equivalent fraction will be 2/8. Whatever number you choose, do the same to the top and the bottom. So, good luck doing equivalent fractions and finding whether or not they're in simplest form.